Okay, so we're building these AI agents that can do some truly incredible things. But here's the catch. With every single new capability, we're also creating a brand new and honestly a very vulnerable attack surface. So the critical question really becomes, how do you protect something that's designed to think for itself? Let's explore a solution.
So, your AI agent is live. It's out there, interacting with your users, accessing data, acting on your behalf. But are you absolutely sure it's safe? Can you guarantee 100% that it won't be tricked into leaking sensitive info or worse, executing some malicious command?
And if you're wondering why this matters so much, well, let's just talk numbers for a second. $4 million. According to IBM, that is the average cost of a single data breach. Now, imagine you have AI agents handling tons of customer data. Suddenly, that risk isn't hypothetical anymore, is it? It's a multi-million-dollar liability just waiting to happen.
Now, the threats we're really talking about here usually fall into two big buckets. First, there's accidental PII leakage. That's your personally identifiable information, stuff like social security numbers or emails. And second, you've got malicious prompt injections. That's where an attacker basically tricks your agent into ignoring its programming and doing what they want.
All right, so we've laid out the problem. The solution, thankfully, is built on a concept that every developer out there is going to be familiar with, a firewall. But this isn't just any firewall. It's one built specifically for the unique challenges of AI agents. We call this firewall agent control. Think of it as a centralized guardrail, right? It governs your agent's behavior at runtime. And here's the most important part, the real game changer. It lets you enforce all your security policies without ever having to change your agent's code. A great way to think about agent control is as a dedicated security guard. It literally stands between your AI and the rest of the world, inspecting every single piece of data that goes in and comes out. It's always on, always monitoring, always filtering, all to keep your agent, and more importantly, your data, totally secure.
So how does this AI firewall actually work? What's going on under the hood? Let's break down its core component, the evaluation engine.
The architecture is actually pretty straightforward. It's built on three key pieces. First up, you have the SDK, which is just a lightweight library that you integrate right into your agent. That SDK talks to the server, which is basically the central brain of the operation. And finally, inside that server is the engine. And that's the part that runs all the actual security checks. Now, the fundamental building blocks of this whole system are what we call controls. A control is really just a security rule that you get to define. And for every single rule, you specify three things: what data to look at, how to look at it, and crucially, what to do if you find a match. So how does a control actually check the data? Well, it uses something called an evaluator. You can think of these as your detection engines. For example, you could use a regex evaluator to hunt for a specific pattern, like a social security number, or maybe a list evaluator to check against a set of forbidden words. And what happens if an evaluator actually finds a match? Well, that's where the action comes in. You decide what happens next. You can set it to deny and just block the response completely, or you could warn, which logs an alert but lets it pass. You could even steer the agent towards a safer, predefined response. You're in complete control. Okay, let's put this all together and see how it flows. First, your agent gets ready to do something, maybe call an LLM. Before it can, the SDK intercepts that call and sends the data over to the central server. The server then evaluates that data against all of your active controls. If any control gets a match, its action, like deny, is enforced instantly. It's a really simple but incredibly powerful security loop.
Okay, that's the theory. But how does the system actually hold up against the real-world threats we talked about earlier? Let's walk through a couple of super practical examples.
Let's take that support bot leaking a social security number. With agent control, the solution is just remarkably simple. You just create a control, pop in a regex evaluator that spots that 9-digit SSN pattern, and if it finds a match, the deny action kicks in. Boom, that message is blocked before it ever leaves your system. Problem solved. And what about prompt injection? So an attacker tries to feed your agent some malicious input, but because you have a control that's evaluating all inputs before they even reach the agent, well, that malicious pattern gets detected and the attack is stopped dead in its tracks. It's blocked at the front door. The agent never even sees it. Look, blocking individual threats is one thing, but the real power here comes from having everything centralized. This isn't just a bunch of rules scattered all over your code. It's a unified command center for all of your agent's security.
And that command center is a visual dashboard. From one single place, you can build new security controls without writing a line of code. You can monitor all your agent activity in real time, see analytics on the threats you're catching, and even test new detection patterns safely before you ever deploy them. And this is the real game changer. Just imagine a new threat pops up. Normally, you'd have to scramble, change code, and push a full redeployment, right? With this system, you just log into the dashboard, update the rule, click save, and that protection is live across all your agents, instantly. No downtime, no code changes, no waiting around. Of course, with any security layer, the big question is always performance. Is this thing going to slow my agent down? Well, as you can see, it's designed for minimal impact. I mean, even when you're running 50 different controls, the added latency is just a few milliseconds. It's absolutely built for production speed. So, what's the big takeaway here? It really all boils down to one word: confidence. By decoupling your security logic from your agent's code and managing it all from a central hub, you can build and deploy powerful AI agents knowing that you have a robust, adaptable, real-time safety net always in place.
So I'll just leave you with this thought. Your agent is out there right now representing your company, talking to your users, and handling their data. Isn't it about time you gave it a dedicated security guard?